Welcome to the DM Circuits Lab. Let's do part 1 series circuits. We're going to build this circuit in multisim and use our virtual meters. Okay, as usual, we're going to build our circuit, and first thing we need is a ground. So we're going to go to sources, power sources, ground. Even though our drawing doesn't show a ground multisim, we're going to have to use it. So let's go to DC power. 12 volts, it's already right. So let's go ahead and go to basic. And we're going to do resistors. And we need a 7.5K. Okay, and we're going to need a 10K. Okay, and let's rotate him 90 degrees so we could lock him in, and we need a 15K. And we have our circuit. And let's go get some DMMs. We'll just put him there for now. Close this out and let's zoom in on it. Zoom area. Let's call that done. Each resistor and the total resistance. So first thing I need to do is let's go ahead and we're going to get rid of our ground. So we need to get rid of our battery. We can't measure resistance with our battery on. So let's hook our ground up here, and we're going to go here, and we need to complete the circuit, and let's turn it on. And we have ohm DC and turn it on, and we have 32.5. So let's see, 10, 15 is 25. Let's enter. Perfect. Okay, so let's turn off our thing, and now let's go ahead and let's remove our meter, and we'll keep our ground there. Close out of that. And now we're going to have to get rid of all of our connections because we can't measure resistance while it's still in the circuit. Alright, so we're going to copy and paste all of these. So we need 3 meters. And being this is multi-sim, they should be exact. Messy but effective. So and turn it on, and we got 7.5, 10, and just like we expected. Let's go ahead and measure current. Being that this is a series circuit and it's not worth the aggravation to start opening things up, let's just go ahead and take one reading, and that should be enough to get us total current, which is equivalent to all of our and I have 0.369 microamps. So 12 into, let's just do a quick calculation here. So we have 7.5 plus 10 plus 15. And I have 32.5K. And it comes up to 369. Perfect. Okay, we could build this from scratch, but let's go ahead and reuse, since all the components are the same. Let's go ahead and reuse all the parts. Okay, so let's rotate this guy 90 degrees. Doesn't matter which direction. 15, rotate 90. And let's put them in the order that we have them here. 15, 10, 7.5. Good. Let's just go over here. Okay, it's still, we increased the voltage to 15, so we need to change our battery. Perfect. And that looks good. Okay, it wants us to measure the voltage of each resistance, but as you remember, a parallel circuits, the voltage is the same across all of them. So we could break the circuit up and measure it. But since it's not necessary, there we go. That's our total resistance. Excuse me, our total voltage. Okay, let's turn off our circuits. We can make some modifications here. And we're going to need at least 3. We already know that, not sure we're going to need 4. So let's get 4 meters. Let's put this one over here, get rid of this. Okay, so we're going to have to break the circuit, so let's go ahead and do that. So we have minus and plus, and it really doesn't matter which way our DMM is facing, because if you put it in backwards, you're just going to have to reverse the current, whatever it reads. So we need to be careful to make sure that our circuit is the same and that we don't break it. And a couple of these are going to read backwards, if not all of them. Let's see. Yeah, they're all going to be backwards, except for maybe the first one. So let's run it. And we need current, current, current. Yeah, good job. I got them all running backwards. Current. Okay, so our total current is 4.5 milliamps. And IR3 is 1. IR2 is 1.5. And IR3 is, actually I got them backwards. That's IR1, so 2, 1.5, and 1. So let's add them up and they should come out to 1.5. 4.5 is 2, that's 3.5 plus 1, 4.5. Good, we have the total current of our circuit.